Welcome to our lesson today. My name is Purity Anzelimo, and our today's topic is differentiation. And in this lesson, we are going to cover the last bit in this topic, that is differentiation, and our last part is maxima and minima. Maxima and minima. In the previous lesson, we were looking at applications of differentiation in calculation of distance, in calculation of velocity, and in calculation of acceleration, whereby we said velocity is ds, where s is the displacement, all over dt, where t is the time. Then we said acceleration is dv, all over dt, where v is the velocity and t the time. And I remember when we were looking at this velocity acceleration, there's something that we said that we are going to apply in maxima and minima. We said when we want to calculate the maximum velocity, at maximum velocity, we said therefore that the ds all over dt is equal to 0. At maximum velocity, ds all over dt is 0, meaning that the gradient is 0. It is at the turning point. Again, at the maximum acceleration, also dv all over dt is equal to 0. Now, we are in maxima and minima. At maxima and minima, the gradient function is equal to 0. That is for maxima and minima, the gradient function is 0. The gradient function is 0. It can be maybe the maximum area. It can be quantities like maybe area. It can be volume. It can be the velocity, acceleration, all these. So for maximum area, the gradient function is 0, or the equation that will give us the area is equal to 0. And also for minima, either for maxima or minima, the gradient function is 0. Because remember we said at the maximum and the minimum point, maximum and minimum point are turning points. Remember we said that maximum and minimum points, we said that they are stationary points. These are stationary points. They are stationary points. And these stationary points, their gradient of a stationary point is equal to 0, both for maximum and minimum. So we are going to do some examples so that you can understand more how to calculate maximum and minimum. That is, it can be area, volume, acceleration, velocity, or any other quantity. So I'd like us to do the following examples so that you understand it better. Question number 1, a farmer, can start with this, a farmer has 100 meters of wire mesh, 100 meters of wire mesh to fence a rectangular enclosure what is the greatest area, he can enclose, with the wire mesh. So that's the question. Maximum area. A farmer has 100 meters of wire mesh to fence a rectangular enclosure. What is the greatest area he can enclose with the wire mesh? So he is using the 100 meters of wire mesh to fence a rectangular enclosure. Then we are asked to calculate the greatest area he can enclose with that wire mesh. So we need to consider this is the rectangular enclosure. This is rectangular. So if we can take x to be our length, or any letter, like even y. So we can take x, this is our length, and we are told that the length of the wire mesh is 100 meters, so we can take this one to be x meters. And because all of it will be 100 meters, it simply means that if our length is x, again the other side will be x meters. We need to calculate the value for the width. So in our case, we are going to have the width as we have 100 is equal to this side x plus x, then plus the two widths. We have this side and this side, and therefore we are going to have then plus the width plus the other width. This one is going to give us the 100 meters. And therefore, when we want to get the width, therefore, it means that width, therefore, will be equal to the 100 minus x plus x, which is 2x. And because these are 2, and we want to get 1, we divide this by 2. And therefore, the width will be, this is the same as 100 all over 2 minus 2x all over 2, which will be equal to 50 minus x. So the width is 50 minus x meters, and this is x meters. And therefore, we need to get the equation for the area. We get the equation for the area. So we need to get the area. So our case for an area, that is for a rectangular enclosure, the area is given by length times width. So our area is length, our length is x, and our width is 50 minus x. And therefore the area will be 50x minus x squared. So area is equal to 50x minus x squared. And the question is asking us to get the greatest area he can enclose with the wire mesh. And we have said that for maximum, for any maximum, the gradient function is 0. So we need to come and say, therefore, at the maximum area, therefore, the dA all over dx should be equal to 0. It should be equal to 0. So we are going to equate that equation to 0 so that we can get the value of x. Then we can be able to calculate the maximum area. Therefore, we get our dA all over dx. We are differentiating that equation for area with respect to x. So we are going to have, this is 1. So we have 50x, 1 minus 1, then minus 2x squared minus 2. So we end up getting 50 minus, this is minus 1. So we have 50 minus 2x. And therefore, we have our dA dx, our dA all over dx equal to 50 minus 2x. And we have seen that for maximum, dA dx is equal to 0. So we equate dA dx to 0. So we have 0 is equal to 50 minus 2x. And therefore, when we take 2x to the other side, we have 2x is equal to 50. And therefore, x will be divided by 2, that is 25 meters. So x is 25 meters, that's the length. The length is 25 meters. We have this as 25 meters, so we have the length as 25 meters, and the width is 50 minus x. So 50 minus 25, again we have it as 25 meters. And therefore, the maximum area will be given by the length times the width. And our length here is 25 meters. The width is again 25 meters, which will give us 25 times 25, that is equal to 625 square meters. So that gives us the maximum area. So we have seen that at maximum or at minimum, it simply means that the gradient function is equal to 0. So we need to get the area, the equation for the area, which is this. Then after getting the equation for the area, when we get the gradient function, we equate it to 0. We find the value of x. Then with the value of x, we can now be able to get the area. So therefore, the area will be equal to 625 square meters. Another question, again on maximum and minimum. We need to do another question. Question number 2. Maximum and minimum. So we have the following. This is number 2. The figure, we have the figure below. The figure below shows a rectangular sheet of metal, and these are the measurements: 8 centimeters by 5 centimeters. Then we are told that the shaded areas, the shaded squares, we have some squares that have been shaded. The shaded squares, each of side meters are removed. They are removed, and the remainder, and whatever remained, and the remainder folded. The remainder is folded along the dotted lines, to form an open box. So this is what we have been given. This is how the rectangular sheet looks like. And then we have the squares which are being removed. So we have it this way. Then we have squares being removed. So we have this one, and we have the other part there. So these are the shaded squares, and we are told that their length, the shaded squares, each of side x centimeters, these have been removed, this one, and again we have the other one here. So they are removed, and we are told that they are cut through the dotted parts. So these are dotted, so they are cut. Then we have this again. They are cut along this. That's what we have. And then we've been given that the distance from this point to this point is 8 centimeters. And then we have from this point all the way to this point is 5 centimeters. So part A, find an equation for the volume. Find an equation for the volume of the box, in terms of x, So that's the first part. So that's what we have. We have a rectangular sheet of metal. The side is 8 by 5. The shaded squares, each of the side. So each of these, the side is x centimeters. All sides, that is x centimeters. We are told that they are removed and the remainder is folded along the dotted lines to form an open box. So this is what we are going to form when it is folded. It is forming the open box. So we can have the box here. We have the open box that is being formed, an open box. This is what we have for the open box. So in this, we have from here up to here 8 centimeters, but these two have been removed. So we have 8 minus x because there is an x here and another one. So we have, on this side, we'll have 8 minus x minus 2x. We have x and x, so it is minus 2x. And these are in centimeters. Then again, on this side, we are going to have all of it is 5 minus x and then minus the other x. So it is 5. We are going to have 5 minus 2x, and these are centimeters. Now we'll have our height. Our height, if this is removed, our height now will be this x. This is the length, the width, and the height will have the x centimeters. So in our volume, we are going to have, therefore, the volume of this box is given by length times width times height. Our length is 8 minus 2x. Our width is 5 minus 2x. Our height is x. So we can open this bracket first, whereby we have 8 minus 2x. We multiply by 5 minus 2x. Then we are going to multiply by x. So we have 8 minus 2x. We multiply by 5 minus 2x. So in this, we are going to have 8 times 5, that is 40. Then we have 8 times negative 2x, we have negative 16x. Then we have negative 2x times 5, that is negative 10x. Negative 2x times negative 2x, we have positive 4x squared. Then if we solve this one, we are going to have these are like terms. So we have 40 minus 16, negative 16 minus 10, we have negative 26x plus 4x squared. Then all of it, we multiply by x so that we can get our volume. Therefore, our volume will be 40x minus 26x times x, that is 26x squared, then plus 4x squared times x, that is x cubed. So that will give us the equation for the volume of the box in terms of x. So the volume, therefore, is equal to 40x minus 26x squared plus 4x cubed. So that is the equation for the volume. Then part B of that question, this is what we have been given. So the next part of the question, the first one was finding the equation. Then Roman 2, on the part B, we are told B, find the value of x that makes this volume a maximum. Again, in this value of x that makes this volume maximum, so at the maximum, we know very well at the maximum we know that dv all over dx will be equal to 0. So we want to find the value of x whereby dv dx is equal to 0. So we have v equal to 40x minus 26x squared plus 4x cubed. So our we have our dv all over dx, which will be equal to, we have 1 here, so it will be 40x1 minus 1, then minus 2 times 26, that is 52x squared minus 1, then plus 4 times 3, that is 12x cubed minus 1, which is 40 minus 52x, then plus 12x squared. So we equate this to 0. So we can write it, we can start with 12x squared, reducing powers of x, minus 52x. Then we have plus 40 is equal to 0. So we want to get the values of x. We get the values of x in this. So this is a quadratic equation. So we can divide all through to make it simpler. We have a common factor here, 12, 52, and 40. The common factor in this, for 12, we have 52, we have 40, we have 2, 6, 26, we have 20, we have again 2, 3, 13, and 10. So the common factor is 4. So we're dividing by 4. All through, we are going to get this by 4, that is 3x squared minus 52. When we divide it by 4, we get it as 13x, then plus 40 by 4, that is 10. 0 divided by 4 is 0. So we solve that quadratic equation. We solve the quadratic equation to get the values of x. And then we are going to get the value for x whereby the volume is maximum. So in this, we are going to have 3x squared minus 13x plus 10 is equal to 0. We can use one method of solving quadratic equations whereby we get the roots. So in this case, our sum is negative 13 and our product is a times c, which is 3 times 10, that is 30. So we get the roots. So we have the roots, we can take negative 10 and negative 3. When we add, we get negative 13. When we multiply, we get 30. So therefore, we have 3x squared, then minus 10x minus 3x plus 10 is equal to 0. So we factor out the common factor here, which is x. So we'll have x minus 10, then minus, our common factor here is negative 1. So we have here, this is x minus 10, sorry, 3x. We have 3 here, 3x, because 3x times x is 3x squared. So here we have 3x minus 10, so that when we open, we get negative times negative positive is equal to 0. And therefore, we have this, which is the same as this. So we have the first one, 3x minus 10 is equal to 0. 3x will be 0 plus 10. 3x is equal to 10. So our x in this therefore will be 10 over 3. And our measurements were in centimeters. Then in the next one, we have x minus 1 is equal to 0. And therefore, in this case, we have our x, which is equal to 1 centimeter. So we want to see when the area, because in our case, we are told when the volume makes the volume a maximum. So we calculate the volume when x is 10 over 3 and when x is 1, and see which value of x will give us the maximum volume. So we can start with when x is 10 over 3, when x is equal to 10 over 3, we are going therefore to get the volume. This is the formula for the volume. So our volume therefore will be 8 minus 2x. So we have 2 multiplied by 10 over 3. We have that. Then multiplied by 5 minus 2x, which is 10 over 3. Then multiplied by, we multiply this one again by x, and our x is 10 over 3. That is for that. So we are going to have this one is 8 minus, here we have 20 over 3, multiplied by 5 minus 20 over 3, multiplied by 10 over 3. And we get our volume. For that case, we can calculate it and get the volume when x is 10 over 3. Therefore, we are going to have 8 minus 20 over 3. Then we have multiplied by 5 minus 20 again over 3. Then we are multiplying again by 10 all over 3. So in that case, we are getting it as negative. We have negative 7, 11 over 27. That is the volume, and this one is in cubic centimeters. Then let us see again when now x is equal to 1 centimeter, we find volume, and the volume is being given by this. We can take it from here, 8 minus 2x multiplied by 5 minus 2x multiplied by x. So we are going to have 8 minus 2 times 1, which is 6, multiplied by, this is 1 times 2, we have 2, 5 minus 2, we have 3, multiplied by x, which is 1. So we end up getting 18 cubic centimeters. So you can compare these two. Actually, volume cannot be negative, and therefore the maximum volume is when x is equal to 1 centimeter. And therefore, find the value of x that makes the volume a maximum. Therefore, the x, when the volume is maximum, is equal to 1 centimeter. X is 1 centimeter when the volume is maximum. When the volume is maximum, therefore the value of x is 1 centimeter. This one we cannot consider it because it's actually a negative. If the negative was not here, we have 7, 11 over 27. Again, the answer would be this because this is the maximum volume. So this one is negative. Volume cannot be negative. So the volume is maximum when the value of x is equal to 1 centimeter. So ensure that you do the following exercise. Question number 1. A piece of wire 18 centimeters long is to be bent to form a rectangle. Its length is x centimeters. Obtain an expression for its area in terms of x. Hence, calculate the dimensions of the rectangle with maximum area for this expression. Then question number 2. find the maximum area of a rectangle whose perimeter is 50 meters and its length is x meters. And its length is x meters. Finally, a piece of wire 8 meters long is to be cut into 2 parts. If the parts are bent to form a square and a circle respectively, find the radius of the circle if the sum of their areas is maximum. Calculate those questions. Remember, for maximum and minimum, when you find the gradient function is equal to 0. That marks now the end of this topic, that is differentiation, the last part, maxima and minima. Ensure that you do other several revision questions from the topic. Thank you. Let's meet next time.